Olá, é um prazer falar com vocês. It's a pleasure to speak to you. I'm going to be sharing with you some of the views which have been behind the vision which enabled us to construct RenovaBio and Rota 2030, which is another regulation which has involved criteria for increased efficiency in mobility. Let's proceed. Well, essentially, what are we talking about? Thank you. So I'm going to be talking about Brazil's bioenergy strategy, okay? First of all, why energy in transport is so important? Well, if you look at which are the countries where energy in transport is most significant, the 4 BRIC countries are within the 6 largest users of energy in transport, which is amazing. The largest user is the US with 581 million tons per year. Second is China, makes sense, 1.3 billion people. Brazil's third, ahead of India. Brazil with a population of 208 million people, ahead of India with 1.3 billion. And this is very important, very amazing, and that's why if we want to do something about global warming, we have to address the issue of energy transport. Second, greenhouse gas emissions in CO2 equivalent in generation and use of energy by sector in the world. In origin, you can see 23% comes from transport. In the world, a majority of emissions come from electricity and heat. Makes sense? But 23 is energy transport. In Brazil, it's 43%. We cannot address global warming in Brazil without addressing energy transport. And this is valid for many other countries as well. The problem, at least in Brazil, is the fact that what I call the heartbeat curve, which is this. It's the very volatile share of ethanol in auto cycle fuel consumption. You can see in the past few years it has varied from 30 to 46. And this is a reflection of the lack of policy. That's why we tried to overcome this problem with RenovaBio, and now we thought that 2030. And also this industry, biomass and sugarcane industry in Brazil is very relevant not only for liquid fuels but also for power. 8.2% of power generation in Brazil comes from biomass, which is mostly cane. And sugarcane is the second source of energy supply in Brazil, only behind oil and natural gas. So, of total energy supply, sugarcane accounts for 17% of Brazil's energy supply. Oil is 36%, ahead of hydro, which is 12%. Mm. So what is the vision which has been behind this idea? It's the vision that it's possible to enlarge the use of high density, low carbon liquid fuels, stimulating higher energy efficiency and lower environmental footprint, complementing in a virtuous way renewable and traditional fuels. This is very important. Brazil in 5 to 6 years will rise extraction of oil from 2.6 to 5.5 million barrels per day. It will go from 9th to 4th largest oil producer. Using the existing infrastructure and promoting local technologies in fuel production, in automobile technology for local use and exports. And essentially this assessment in the axis shows greenhouse gas emissions in grams of CO2 per kilometer, in the Y, energy consumption in megajoule per kilometer. And you can see here, in this black line, in the northeast part of the graph, the emissions and the energy consumption of a typical internal combustion engine using gasoline with zero ethanol here. So it's emitting 144, 146 grams with an energy consumption of 1.62. This is going to evolve this way until 2032. Here is the hybrid using gasoline with zero ethanol. Today, it's going to move this way. Here is the electric battery car in Europe and the US using the mix of electricity, renewable and fossil, in Europe and the US. It's here, so it has lower energy consumption and lower emissions, but it's here, and it's going to evolve this way. Here is our ethanol, internal combustion engine with a similar energy consumption as other gasoline cars, but much lower emissions. Actually, emissions which are lower than the electric battery car today and in the future. But we need to improve energy consumption. That's what Marcos, the FCA announced. That's the pathway that they're going to follow, this curve. Here is the hybrid car. Toyota, which is going to be starting to be sold in Brazil in October. Very little emissions. It's actually the only car today which is able to comply with this credit here, which is the target for Europe beyond 2032 in terms of emissions. And very soon, also in terms of energy consumption. And here is the fuel cell, using ethanol, which is the electric car using biofuels. If we were to summarize emissions only, this graph summarizes emissions for all these options. Here we have the internal combustion engine, gasoline car, 145 grams today. In the future, it's going to be 127. The hybrid using gasoline is 122, going to 98 in 2030. The electric car in Europe, 92, going to 74. Our combination here in Brazil of gasoline plus ethanol, 87, better than the electric car. Even the gasoline combined with ethanol is better than the electric car. Here's the electric car in Brazil, using Brazil's renewable power, 65, going to 42. Here's the hybrid, the internal combustion engine, flex using ethanol, 58, going to 47. Here's the hybrid, Toyota, 39, the cleanest car, going to 27, and here's the fuel cell. What is the problem with the battery? Is the low density of the battery. The battery is only a container to store energy. It's not the energy itself. And the energy of batteries is very low. It's 130 megawatts per kilogram today, which is here. The target of the industry is to go to 330. One day, if everything goes well, it may go to 700 or 800. Okay? What is the energy density of ethanol? 6,200. And essentially, what we are defending is electrification with biofuels. Nissan, in June 2016, said this: with the current ethanol distribution system, Brazil has already solved the hydrogen distribution hurdle. This electrification does not use rare metals, and distribution of ethanol alone or blended in gasoline is equivalent to a network of hydrogen. This is the stoichiometric equation of this engine. Ethanol plus oxygen produces CO2 plus water. CO2 is reabsorbed by the C4 sugarcane. So we're producing water vapor. It resolves everything. So we believe that the pathway to be followed is first, optimization of the internal combustion engine, which is what FCA is doing. Second, the hybrids using ethanol, which is what Toyota is doing. And third, electrification using ethanol and biomethane. We are moving towards the age of hydrogen, yes, but not hydrogen contained in titanium tanks at 700 bar. Hydrogen contained in liquid fuels with low carbon footprint, like ethanol, biomethane. So, what is the advantage of this? It takes the advantage of the high energy density of ethanol, avoids the trap of fossil-derived electricity, has the lowest greenhouse gas emissions, uses the current existing infrastructure. EPE here, the company, state company which is in charge of doing energy planning in Brazil, concluded that the required investment to establish a network to refuel batteries would cost Brazil $210 to $330 billion. Is the equivalent of all the savings which is being attempted with the pension fund reform. We would avoid concerns about availability and sourcing of lithium and cobalt. The lifespan of batteries, which is only 4 to 5 years, and they have to be discarded. There is a pollution related to them. And finally, you create jobs and income. This is the history of development of many places in Brazil and around the world. We have to place in our heads, biofuels is solar energy captured, stored, and distributed in an efficient, economical, and safe manner. It is hydrogen captured, stored, and distributed in an efficient, economical, and safe manner. We have on our side many people. At COP23 in Bonn, 19 nations representing over 50% of world population, plus the International Energy Agency, plus IRENA, and IEA has always been fossil oriented, but now they're changing. What did they say in this declaration? That for us to meet the 2-degree scenario, the target until 2030. 2030 is like planning next weekend's vacation. Has to be the proportion of bioenergy in world energy demand must double, and the proportion of sustainable biofuels must triple in proportion. What IEA and IRENA are saying, we have to rise current production of biofuels from 130 to 500 billion liters until 2030. That's 370 billion liters more, 10 times Brazil's production. And by 2050, 1.12 trillion liters. That's them, it's not us saying. So there's a sense of urgency in the world towards this thing. That's why we think that biofuels can resolve the two biggest challenges for humanity, the challenge of global warming and the refugee crisis. Because if we convince people in Africa that they could increase food production and biofuels production along with it, we would resolve the refugee crisis on a replicable and scalable way.